So this is a dessicator, and underneath you've got the drying agent, and then you have a wire mesh where you can just drop this. I can just decide to drop this and then cover it and walk away. That is fine, absolutely fine. But remember that because there are air in there, you are bound to have some moisture. And remember, I'm trying to dry this. So the simplest way to do this is to connect this again to a vacuum pump. Why am I connecting this to a vacuum pump? Because I want the vacuum pump to take away all the air that I've got in there. That facilitates the drying of this. Okay? So just leave it for a bit, and then after some time, you can turn this off and turn that off and leave it to dry. Come back to it later, get your mass, and then try to weigh. So this screw has got something so that once I screw it in, it blocks the air. So that when I remove this, air doesn't rush in. So right now, it's tightly held. Remember that there is no way for me to cork this. But because I've removed the air in there, I can no longer open this because everything is now sealed. I've created a vacuum in there. So now I can leave this for a while and allow it to dry. And after that, I can get this and then weigh to get my practical yield. Okay, so having dried this, now this is my practical yield. But I must warn you, remember that during crystallization, that after the reaction, what we did was that we placed this in an ice bath because we want to cool the temperature. Now, while we are cooling the temperature, there are possibilities that some sodium sulfate, which although are highly soluble in water, would have precipitated. And if, for instance, we have some undissolved starting materials in that product, they might also crystallize out. So using the ice bath to do that crystallization wouldn't really work well. So all I have to do is to find a solvent that my product is soluble in. So I can get this crude product, redissolve it in that solvent, and then allow it some time to crystallize out. So this product is actually soluble in ethanol, but what we want to do is to have a mixture of ethanol and water because the product is insoluble in water but soluble in ethanol. So we are going to mix up 70% ethanol and 30% of water. The ethanol try to dissolve this, and the water try to cause some of the crystal to come out of solution. So once we've done that, the pure crystal we have will always come out. With that, we can weigh and get our practical yield. Under that circumstance, we are very sure that we've gotten rid of any form of impurity, be it the precursor or the byproduct that we don't want to be part of this product. Okay? So we measure this, and then we have about 1.32 grams of that. So with this, we can run the theoretical calculation and then be able to tell what this practical yield, how many percent it actually represents. So to that, I say thank you for watching and hope you are inspired to do science. Thank you.